So thank you for attending. I know it's lunchtime. I know it's a web talk, and coming after some crazy iOS stuff, it's always hard. But I promise it's going to be cool, and we'll get some live demo at the end. So this talk comes back on Simon work when he was at Thomas. Now it's security engineer at Google, and honestly, all credit is due to Simon because it's all his bug. And if you want to pay beer to somebody, you should offer beer to Simon. He's going to be at the parties tonight. And my name is Thomas. I was working with Simon in the research team at Thomas. And our goal is to find 0 days in open source software to improve our static analysis engines. And I think if you're French, or I think we say European, you know Zimbra. And as a proof, when you Google Zimbra, the first links you get before the official website is public instances of Zimbra, of like ISP providers, universities, governments, everything. But if you don't know it, it's simply an all-in-one mail solution. So that means there is everything, obviously all the basics like IMAP, POP3, SMTP, and you get some crazy enterprise-ready features like collaborative tools. It's like G Drive, but on your own instance. You get chat, you get file storage, you get document editors, you get crazy stuff like legal intercept for law enforcement. Like you can get shadow mailboxes, just mimicking existing mailboxes and to send everything to law enforcement. So it's really enterprise-ready. You get web front ends, and it's missing a S, but there is more than one web front end. You get APIs, mobile application, desktop applications. And it's really popular. Like I said, it's used by universities. Everybody knows it. They claim to have more than 200,000 customers, which is a lot. And they also advertise strongly that governments love to use Zimbra because they get back, the digital ownership of the data and stuff. And as you may remember from all the Exchange stuff, mail servers tend to be touchy because you have to expose your mail server to the internet. Otherwise, you will never be getting mail. And at the same time, if somebody compromises your mail server, it tends to be game over for you because attackers will get access to all your emails, private attachments. I don't know if you're sending your some services, some passwords by email to newcomers. If you're sending confidential data like financial status of your company, it's gonna end up in mails. And if you reset somebody's password, the reset link is going to happen, it's going to arrive in your mailbox. So people tend to be really touchy. And also as a proof, it's really sensitive. There were a lot of recent campaigns in the wild against Zimbra instances. And most of the reports come from Velocity, which is a threat intel company, and they reported several targeted campaigns against Ukraine governments, media customers. Like in February, they tracked down some repetitive cross-site scripting. So you would have to open mail, click a link, and then somebody would start exfiltrating all your emails. And you're like, yeah, but just XSS doesn't matter. But at the same time, it allows stealing all your emails. And then you can send emails to all the address book and kind of chain it and start leaking everybody's emails. So it could be pretty sensitive. And it was 0 day at the time. They claimed it was used by a state actor because there was no financial gain. So the goal was only to leak information from companies. And in August, they also found out that more than 1,000 instances would have like a web shell just waiting to be used. And to drop this web shell, attackers would exploit an authenticated RCE during mailbox import and saying like, yeah, but it doesn't matter, you need an account, so it's like insider threat. But they also found out there was some authentication bypass on this specific endpoint to exploit the RCE. And that would mean that anybody with your Zimbra instance URL would be able to just get code execution on your server, which is not something you really want on your mail server. And let's, put ourselves in the state like we are attackers and we want to get into some Zimbra instances with some nice 0 days. So we need to do some basic attack surface modeling. And first thing you think is, yeah, user-facing services. Everything that's all the Java backends, all the APIs, all the user interfaces. You get front ends, again with us because there are more than one. You get mobile desktop application. And then you also have some internal services because it's enterprise ready. So you have caching, you have synchronization, data replication, you get some maintenance background services that just handle your mail, compresses stuff. You also need to think of incoming emails. If you are not able to receive emails, your mail server doesn't matter, like it's useless. So you need at least to expose all your SMTP ports to receive your emails, and then you need to process these emails, you need to store them, and deliver these emails to the user so you can visualize it from the interface. And among all the services, everything can be hidden, like behind a company VPN or everything, but you always need to expose this incoming email ports over SMTP. And also when you receive incoming emails, you don't want your user to click on all the fancy spam phishing links, malwares.exe in your mails, so you need to scan your mails for that. And today I'm going to present 4 bugs that were found in roughly 3 months of research. I say 3 months because there is always a question like how long did it take, so you already know. We're going to cover user-facing interfaces with a stored cross-app scripting during message display. That means that you receive an email, you open the email, and somebody starts exfiltrating all the contents and your address book and attachments. It can be chained with an authenticated server-side request forgery that can be chained with the aforementioned XSS. There is also internal services will show you how to exploit a new line injection to kind of break all the caching layer and leak clear text passwords of your users. Also going to show all the incoming email processing and how a path traversal in Unrar, like the archive extractor, can be used to get SE on any Zimbra instance. So let's start with the front end. Like I said, you need to display emails because it's the goal of Zimbra, and everything that comes from emails is attacker controlled. So you want to display message bodies, but you cannot just strip every HTML tag because you have fonts, you have colors, you have images, you have buttons. You also need to preview attachments to make sure that like it's fancy. Like when you receive a document, you want to kind of maybe show previous visualization of this document, and to kind of reduce the risks, so backend sanitize email bodies. That means that only safe tags and attributes will be allowed. In that case, only images, and I don't want to have the on error or on load, on click attributes on my image, so nobody can execute JavaScript code. And to that end, they use the OWASP Java HTML sanitizer. And we didn't really discover bypass for the sanitizer because it's complex, it involves parsing XML. I mean, sometimes you want to be lazy and just try to go for the simplest thing. And when you see sanitizers, when you see validation, there is one simple trick that sanitizer hates and that we love. It's nothing new, but we try to give it a name for ourselves because we don't know what it's really called. But there is one thing, which is that application tend to modify sanitized data. So we call it sanitize, then modify. And this transformation after sanitizing the data can negate the effect of sanitization. So you don't need to worry about the sanitizer. You just take a look at the big picture and you're like, okay, it's sanitized, doesn't matter. If I can find any other piece of code, maybe somewhere in the front end, somewhere like really far away that modifies my data, maybe I can break this sanitization and do something interesting. And this is kind of the concept behind mutation-based XSSs, which is nothing new, but it's still very much alive in these days. And we found several bugs this way, like there were some WordPress, CSR2SE, Magento pre-auth, stored XSS, MyBB chains. So it's a real thing. And to give you an example, let's try to show some code. So it's just doesn't matter, it's like pseudocode. I take my user input, I transform it. Transformation in my case of email could be transforming my HTML emails to XML, removing images, entering text, doing some fiction checks. Then I may want to normalize it because maybe I broke something in this process. So I want to do some sanity checks, make sure that all the links point to a valid destination. And then I sanitize my data, I remove everything that could be dangerous, and then I use it. And in some insecure example, I would rather sanitize everything and maybe normalize my data and maybe transform my data and finally use my data. And in these two last steps, normalization and transformation, we may break all the sanitization that happened before. And in Zimbra, it's exactly what's going to happen. I think you guessed. We have 3 different front ends. There is the advanced one, which is the default one. It's like Gmail, you get fancy, animated, dynamic front end, and you can fall back to the old HTML client. It's exactly the same. And in the modern front end, you get preview of attachments with JavaScript done on the front end. So you can integrate PDF documents, calendar invitations. So let's start with a simple, which is safe for now, email body, which is HR, which is a new line. We get a line with an attribute and no shade, also styling attribute. And I mean, there is nothing dangerous. There is some script alert somewhere, but it's an attribute, so it's not doing anything unsafe. And after server-side sanitization, all the angled brackets are being transformed to the, encoded counterpart. So LT is for the left angle bracket and GT for greater than, so right angle bracket. So yeah, it's still safe, still sanitized. This is a sanitized step. And if we come back to the front end, after the backend sanitized everything, we put the email to the front end and we process it. And in the case of mail invites, it goes through something called truncate body content, which looks like some transformation step. And first, it will normalize the HTML. So remember, everything is sanitized. So it will put all the HTML into some div element it just created, and the browser is gonna normalize it, make sure like there is no broken tags, nothing. This is the kind of places you look for mutation-based XSSs usually. But in this case, everything's safe. It's already sanitized. And it's gonna return this data as a string. So a string representation of all the DOM tree that was inserted in there. And this is a normalization step done by the browser. And the result of the normalization, we're back in the original state. The browser decoded everything, and it's still safe. But at some point later, they apply regexes to make sure there is no form tag, the thing with buttons and stuff, without an action. Because the action field, if it's missing, if you click on a button, it's going to submit it on the page itself, and you don't want to do that. So it's replacing all the form tags with an action that points to same host for post blocked, which is just something that doesn't exist to prevent some kind of attacks. And this is a transform step. And as we see, it's processing here. The data is processed as a string. So we're applying regexes on structured data, which is a string. So after transformation, the form tag that was in the attribute will be replaced by the regex, and the regex will introduce a new quote that will imbalance the quote and break out the sanitized code. So we end up with some script alert that is, I can show you, that is here, that will be evaluated by the browser. So this is the use tab, and it's basically an XSS. So we were able to, by sending this new line for the execution of arbitrary JavaScript code when you open an email. And in that case, processing structured data as a string is always bad. Like, we can blame them. Processing HTML and XML, it's never easy. And using this thing, we can exfiltrate target's mailbox when they open the email. And then we can scrape the address book, send it to everybody, they open emails, that scrape the address book, open emails, send everything. And then we can look for post-authentication bugs now, because we are running in the context of the user's tab. And as a feature, there's something called proxy servlets that allows getting around same origin policy. So it's used for the integration of third-party services. It's a feature, like your browser is not allowed to ping zoom.com or webex.com. You have to request a server to do it for you. So they restricted to another list of domains, and by default, nowadays there is only webex.com that's allowed. So it looks like it could be safe. And the goal of this proxy is to proxy your request. So it's taking every single existing header, only the one which are allowed. So it's removing header like host, like content length, for instance, to kind of make a safe request. But if we look at this line, we see that if there is a header from the request that's called xhost, we can change the host header of the request. We are still only allowed to fetch webex.com subdomains, but we can set the host header, which is going to be important for later. And when processing the response, if it's not a post or a put, it's using a default redirect strategy. That means that it will follow redirects. So what we have right now is that we control many headers of the proxy request, including host. We can use any HTTP method. Redirection are going to be followed by the HTTP client in some cases, and we have full access to the response because it's a feature. We only need to find a redirect based on the host name. And at the time, that was the case for blog.webex.com. It was a WordPress site, and when you would ping this host with HTTP, it would do a redirect to the HTTPS version, and to craft the URL for the redirection would use the HTTP host header. So we would have this kind of open redirect that we could chain with the SSRF to reach internal services. And I'm going to show you what it looks like with a quick demo. So this is what it will look like for an attacker to kind of set up everything. I'm not going to show any technical detail. You already got everything. So we launch the attack, which sends an email to the employee, and then the employee logs in because you need to check your email from time to time. We get a nice dog picture. It's cute. Everything's nice. And in the background, we have some JavaScript being executed. So the attacker can come back on the, let's say, CNC, and we get access to leaked emails. So we have like the Office banter email. We get this fancy access to production environment email also. It could be interesting. And we can leak, in the case of like Zimbra being hosted in the cloud, we can also leak like AWS credentials and user data and stuff. And in this case, it's never easy in real life, or is it? But you get some root production password for somebody. So what we have so far is we can compromise user mailboxes with user interaction by sending emails. We have some post-out SSRF, but no free SE on internal services. And it only affects users of the web frontend. And I mean, it's good enough for state actors. They use the 0 day while people have to click on a link to leak their email. So it's good enough, but maybe not for us. So now we can look at all the infrastructure. Zimbra, like we said, it's an enterprise stuff, so you may need to provide a single entry point to the infrastructure and do everything you want in the back, but you have only one service listening on the network, like on the public network. So to that end, they deploy a custom Nginx proxy. It's a single patch file because it's GPL and stuff. It's horrible to read, but it exists. And they proxy every incoming HTTP, IMAP, and POP3 traffic. It's not only HTTP, it's really like mail traffic. It's proxied through this Nginx, and it's relayed to backends. And one of the goals of this setup is to configure Nginx to handle multiple domains. So if I have several domains on my company, I can say, okay, my backend server A is going to handle everything for A.com, and my backend server B is going to handle everything for B.com. So to make the association, to know which backend server will have to be reached by Nginx, there is something called Zimbra, the Nginx lookup extension that we're going to call Zimbra lookup service, which is here to do this association. So to show you what it looks like, we have an incoming request from user@example.com that comes from over the internet. Let's say just using the mail app. It comes to Nginx over IMAP. And Nginx says, okay, what's the backend server for user@example.com? And then the Zimbra lookup service replies, say, okay, please use server A. And then Nginx will proxy everything to backend A. So this is like really simple and really smart way to have all these servers in the back. But making this extra XP request every single time, it's expensive. So they introduce a cache layer called memcached, which is, as you may know, some high performance distributed memory of the caching system. In simple words, it's just line-based protocol to set strings, to associate key strings value to key strings. So you store data with a name. And in the future slides, every new line characters will be made explicit. I guess you can already know why. So let's say user@example.com is using Zimbra. So the lookup services, so the request comes to Nginx, the lookup services replies with the backend server to use, in that case localhost, and Nginx adds a route to the cache with the add command. And in memcache terms, looks like this. We have the add, which is the operation. We have the cache key, which is root, proto with the protocol the user is using. So in that case, it's using HTTP over TLS, and semicolon user equals the name of the user. Then we have the flags, which is 0 in this case, doesn't matter. We have a TTL, because this key can be automatically removed by memcache after some time. We have size, and then we have the data which is returned, which is, the data to store, which is the name of the backend server. And there are multiple ways user identified, because there's all these protocols. So for HTTP, it could come from cookies, segments like portions of URLs, could be basic authentication, like small prompt when you have to log in. And for IMAP and POP3, it could be the user. I think it's only the user. So in that case, I will show you what we could do with URL segments. So we have this service, URL. I think it's made to display files, and we have the username in this part. So when you hit this endpoint, which is pre-auth, it's going to make a request. So it's a memcache request. The cache request says, okay, get root for HTTPS for user@example.com. And what's highlighted is what's the same between these two. And the response is, okay, for this key value for user@example.com, you should use a backend localhost. But what happens if you try to add a new line in this case? Like if you, in the URL, you put new lines and something called stats, which is a memcache command. Like for us, it's going to look the same. But remember, it's a line-based protocol. So for memcache, in the end, it's gonna do not one request, but it's not one operation, but two operations. There will be the get for user.example.com, and then there will be the stats command. And if you use TCP dump and try to monitor responses, it's gonna return end because there is no value for user.example.com, which is fine. And then we get the output of stat. So that means we have the ability to inject new memcache commands and alter any entry, because we can get entries, but we can also set entries with add, like Nginx is doing. We can overwrite roots of any non-user. And good thing is all the keys are predictable. Like the protocol changes, it's HTTPS or IMAP or POP3, and the user is the name of the victim, of the target. So we can simply set the cache key for victim@example.com and tell it to use the backend server 1337, and it will, when Nginx will process this request, all the traffic from the user will be redirected to this address. And unfortunately, all the HTTP routes, like all the HTTP destinations, they're checked against non-backend. So it's impossible to attack HTTP or HTTPS connections to arbitrary servers. But for some reason, which I don't know why, it's not the case for IMAP and POP3. So that means that every single time all your make clients like Thunderbird or like online stuff will try to fetch emails, they will come back to the attacker server. And by default, it's TLS. So everybody's putting clear text credentials over TLS because it's safe. So that way you can steal everybody's credentials by hijacking all the IMAP and POP3 traffic. So I have a quick demo for that also. Just gonna explain. It's kind of visual. So we set up a fake IMAP server, then we prepare some data, and then we repeatedly poison response buffer for the user. And I'm just wondering, it's not the right demo, sorry. So I will be back on that later, sorry. Yeah, just slide this morning, it was a mistake. So by overwriting cache entries, Nginx forwards traffic to arbitrary external servers, so it allows stealing clear text credentials from an account. And all the affected endpoints can be reached pre-auth, which is interesting for attackers, and it works for all active clients. And you're like, yeah, okay, but I need to know my victim account. But list of targets, not so hard to establish. You can use LinkedIn, you can use common patterns like first name dot last name, you can use dedicated websites. But still, like, can we do better? Can we remove this from non-accounts requirement? Can we still clear text password from, let's say, everybody or anybody? And so I guess you know the answer is yes, and I'm going to show you how it was done. So the connection to memcache and all the I/O buffers, like all the request buffers and responses buffers, are shared across Nginx worker threads. That means there is one single TCP connection from Nginx to memcache. And the request buffer and the response buffers are like a queue. So it's each worker, they put a request, and they are responsible for pulling the response out of this queue. It's a FIFO stack in a way. And another good thing to know is there is no validation on the retrieve key names. If I'm worker A and I'm requesting key A, if somebody is giving me key B, I don't care. I'm just taking the value out of it. There is room for a lot of race condition bugs in there, but we're not going to look at it. So what it looks like is I'm worker A, doing my get root for a@example.com, and I'm getting my response. And then I'm B, and I'm doing my request and getting some other response, and so on. So it's fairly easy. It's just a queue. At the protocol level, what it looks like is three workers are kind of pushing this request. So get root for A, get root for B, get root for C, and the response buffer is going to be populated with all the responses. So we get response for A, response for B, response for C. And it's simply going to process everything one by one. So A was first request. So first we pass and remove from the buffer everything up to A. We just remove a pointer that goes to the next response. And then same for B. It's going to be taken from by the worker B and going to remove the response for B, and same for C. So this is just the usual process. And there is one thing to know. Sorry. That a parser is a state machine, so it has to know like what it's currently processing. When processing the response body, bytes will be consumed until finding end and a new line, or if the response buffer is empty. That means that the size field is not used, and in the response there is like 14 in this case, which indicates how many bytes of response there are in the reply, but it's not used. It's only looking for end in the response. and combined with something called a bulk request in the case of Memcache. Like you see in this case, we have get, which is the operation, and then we get key1 space key2 space key3. It's going to return something that way, which is value for key1, okay, foo, value for key2, which is bar, value for key3, which is foo bar. But as you see, there is no AND in this case. It's not like the usual responses. And since this is a custom Nginx module, it's made from scratch, it doesn't have support for all these features because it's not used by Zimbra. So we can try to put the parser state machine into the wrong one and make it think that it's currently processing something it should not, and we can try to desynchronize requests and responses. So the exploitation scenario would be to use our ability to do arbitrary cache operation to set any key and get any key, and then we would create a key with AND and a new line, but it would be part of the key value, and then we would inject a second response in there, and then we do a bulk request to populate the response buffer and wait for clients to pick the wrong one. And to do so, we would set a bogus key, which is called injection in that case. So we set injection, and everything that's in green, it's only the value, and as you see, there is AND, but it's not the real AND, because for Memcache, it's using the size field, which is 87 here. It's not stopping at first AND. And then we store something that looks like a will answer, which would be value for X, and some destination server, 13337 in that case. And we do a bulk request with injection by using spaces. And in the response buffer, it's going to look like this. So we get the value for the first example user query. And it ideally, like a correct parser would stop there because the response was 3 bytes, so it should stop at foo and a new line. But no, it's stopping at the first and it finds. So it reads everything up until the fake response. And then for the client, the bulk request is done. But we still have two responses waiting in the queue. So the next one that will be the one with the fake upstream server, and then we're going to have some junk. And to show you what it will look like, one bulk request will be associated with some chunk data, and then still in green on the right, it could be a second response that we injected. It will be given as an answer for the next cache query, and then we also get some junk for the next one, and then we get the expected answers for yellow and green and blue. So that means that attackers can grab the next user clear text credentials, and we can also inject several responses. So multiple cache responses can contain the data, and there is basically no service disruption, but nobody will see it because all the HTTP cache routes are validated, and you can enter your fallback, and we can repeatedly poison this cache and flush it. And now I'm going to show you the demo. So let's start from scratch. So this is just a Go POC that we used. So we set up a fake IMAP server, and then we repeatedly poison the cache. We do this, we set a few keys, and then we do this bulk request to fill up the response buffer. And at some point, the next time somebody will come, if the cache request is associated to the fake upstream server, Nginx will take all the credentials and proxy everything to the fake IMAP server, and we get users' clear text passwords, which is nice. So now we're gonna, wait for the live demo. Now we're gonna attack the email delivery, and I think that's why it's coming like really interesting, because it's like technically really cool. All the incoming emails, as you may know, they are received by something called MTA. In this case, it's postfix, that everybody's using it. And once postfix gets email, it puts it in some, queue, called the active queue, and then it just sits, and then you can try to to process your mail and try to make sure there is no spam or no phishing links. So roughly, you get something from the internet, comes into postfix, it goes into a service called amavisd, which calls ClamAV for virus scanning, spam assassin for spam, and then it circles back into postfix in another queue that is, let's say, ready for delivery to the end user, and then Zimbra can consult emails in this queue. So this central component called Amavis, or amavisd, which is the name of the process, it's an open source content filter. It's written in Perl, it's 25 years old, you know where it's going. It's using a dedicated queue for incoming emails and attachments, and it just supports for everything, because you need to support DKIM. you need to bridge to spam assassin and claim IV. But what if I get a zip file? How can I scan a zip file? I can't, so I have to extract my zip file beforehand. And surprisingly, AMAVSD runs as Zimbra, which is the same user as every other single process on the host. And it's not configured to use any security features. There is no sandboxing, there is no CH routing. And in the configuration file of AMAVS, there is something called decoders, which look like commands to invoke when you are unpacking files. And I mean, why? It's like, this list is like 100 lines long. I didn't even know about the F extension, the Z extension, what is it? And there was just plenty of exotic and completely forgotten file formats. But on the other hand, it's not that easy, because to extract these files, you need to have this software installed on the host, otherwise there is no way to invoke this software to extract the archives. So it kind of reduces attack surface, but we can still try to look for bugs in one of the structures. Could be zip, could be Unrar, but that's something common. And for Unrar, which was picked in that case, there are two versions which are usually deployed. We have the RAR lab Unrar, which is the one made by Unrar that everybody used and paid for. And nowadays it's shipped under the name Unrar on most Linux distribution, but it's not free. But honestly, it's the only one that works. There is also the GNU Unrar, which is also called Unrar free, based on GPL code with basically no feature and no support for anything. And the way AMAVS invokes Unrar, it's using just Unrar, X for extract, and then the name of the archive, and then /tmp, let's say. And one of the strong security assumptions you make in that case is that output files should never be above TMP. Otherwise, you can just smash any file on the system. And when you extract an archive, I don't know, some zip you got from the internet, you expect everything to be below the current folder. You never expect to write some files somewhere else. And to avoid that kind of attacks, it's really tricky, honestly. Like, we can't blame all the developers for this bug, because you need to support cross-platform stuff. Like, I built my archive on Windows, I want to extract it on Unix. How can I do it? It's not so easy. And same, like, or about links pointing to links, or about hard links, or about like a folder, extracting to a folder which is a link to somewhere else. It's not so easy. And you also need to care about absolute vs relative destination. For relative stuff, I mean, it's fairly easy on Windows and Linux. It's just on Unix, it's different, it's backslash and slashes. But for absolute destinations, in Windows, you have the drive key. It could be some SMB share somewhere. I also know there is some crazy stuff with NTFS and like fake virtual drives and stuff. For Unix, it's a bit simpler, but there's still like a lot of hidden complexity in trying to avoid that kind of attacks. And while reviewing all this code, in this case, this function is called extract unique link 50, which is for RAR 5.0 archives. But we see that there is some validations thing happening, maybe, because the function is called isRelative symlink save, so it sounds like validation. It's based on something that's called a variable called redeal name, which is destination of symlink. And if we look before, there is this transformation, DOS / to Unix thing happening, and it will tell me, yeah, but this is done before, so it's like transform and then I validate, so it's safe. But there is something to notice here. It's not the same variable, it's something called target. And in the end, the last line, target is being used. So roughly we copy redeal name into target, then we transform target, then we validate redeal name, then we use target. So the validation step is maybe can be negated with the transform on target that happens before, but that's the one that's going to be used. And on non-Windows build, like when you run Unrar on Unix, it's only preventing symlinks with .. because .. in Unix, it's safe. It's not doing anything unsafe. So it's only waiting .. And in the transformation step in .. to Unix, it's replacing backslashes with slashes. So that means that we can, on any software extracting RAR archives with the official Unrar, we can try to create two entries in a RAR file. So there would be first a symbolic link with the Windows symlink redirection type. The name is, let's call it smash me. It points to .. to escape the validation step. And this thing is gonna be transformed to .. during the transformation step. And then we create another regular file called smash me, which will contain the payload. And then if we extract the archive, something wrong happens because TMP foo is going to be created. And if you trace everything, what it's going to look like, we open test.rar, we extract it, and we see it's creating a symlink to ././tmp4. And then it's writing, it's opening smash me, following the link, and then writing to this new file descriptor, the payload. So we can write, when extracting Unrar archives, we can write to any file on the system. And remember, Zimbra is a web app, so it's pretty standard exploitation. We can use this path traversal to drop a GSP file is in some web server route. In that case, opt Zimbra jetty base, and I guess it's time to trade. So let's try. I have some scripts to monitor what's happening. This is simply just a trace of Amavis. So the goal would be to look at any command that's going to be executed in the context of Amavis. So we can run it. And on my side, I have step 1. I don't really see my screen, which is only a way to create, just raw files. It's really CTF-y. And we have step 2.py, which is only sending an email. So it's going through some proxy because I need it, and it's sending sendme.rar to the mail server. That's it. It's only sending my raw file somewhere. So I will use step 1. I was too afraid to forget past name. And we're gonna use step 1 to create a symlink to ././opt Zimbra, which is a public folder of Zimbra. We're gonna write a file name foo.gsp, and the output is in sendme.rar. And so this is what it looks like roughly. And in our case, foo.gsp is a simple Java shell. So it's executing with here a command in a parameter called cmd. So we're gonna, we already generated the raw file, so now we're gonna use step 2 to send email. And before that, I will just authenticate on my Zimbra. Don't forget my password, please. Okay, I forgot my password. Right. So we have no emails in that case. And I'm going to show you it doesn't even require to open email. So I run step 2. Below we see that there is something happening with amavisd calling Unrar and trying to extract something called P002 in some temporary folder. And we saw that we got some email, but let's skip it. We can just ignore it. And now in the public folder, we have foo.gsp, and ideally, if I put cmd equals, let's say, id, we get some command in Zimbra. And I'm going to also run something like it's Zimbra, it's not root, sudo-l, which shows which command can be executed as root. And it's going to be important for later. And as you see, there's some commands. So what now? We report everything to Zimbra maintainers and say yes, but sometimes Zimbra it's not on the same host. So if you need the backend to get SE, it doesn't work. Yada yada, it. And as you were saying, you can't really argue with a root shell. So let's try to get SE without using a backend and maybe gain persistent as root. There is a daily cron run as Zimbra, and just running on every host where Zimbra is running, which lists every single file called access log in some folder. And then to display it, in Python you would use print, but in that case they create a new process. And in the command line they inject the name of the file they found. So you simply create a new access log with some symbols in the name, and it will execute it one day after. I don't want you to wait for one day to see the demo, so I will skip it. And also another idea, it's like most services, they all run as Zimbra. There were like 63 of them. So there is plenty of room for persistence with the configuration. So if you just compromise the amavis host, you go in the configuration folder and you override amavisd.conf. And next time it's going to be rebooted because you need to do updates because your Zimbra is vulnerable. You can load your own command and backdoor everything. So also, something interesting could be to elevate privileges, like I've shown with the sudo rules. And it's obvious that somebody already did it, like Darren Martin did a release a few I think it's like years ago, because of these pseudo rules that you can execute any of these commands as Zimbra. He found two ways to execute code as root. So using the ZM's labd, which is the LDAP server for Zimbra, and Nginx, it just gives custom configuration, and that ends up calling and loading arbitrary shared library files. It's still unpatched because it dropped everything as full disclosure, because indeed the Zimbra disclosure policy prohibits the publication of exploitation code, which it didn't like, which makes sense. So just rough timeline, because I mean it was pretty efficient in that case. The initial report to Lab was done in May, and 2 days after they released the patch version. So in 2 days it's really efficient. Everybody with vulnerable version of Unrar would be safe. And then Zimbra was notified of the issue, and they patched Amavis to use 7z instead of Unrar, which is somewhat safer. Like, there is not the same vulnerability, but there is still no strong privilege separation between all these processes. Amavis still runs as Zimbra. So to conclude, Zimbra is a new hype, honestly. Expect frequent in the wild bugs. It's so sensitive and so less, let's say, secured and reviewed that all the Exchange and other mail servers. So you should also update your Zimbra every once in a while. And like on the research side, I mean, being creative about attack surfaces really makes sense. In that case, trying to armor the Java backend for days, I mean, it drove Simon crazy. So sometimes switching to other attack surfaces makes sense, and it's not the first time that a random dependency helped us. In that case, Unrar, you would maybe not expect to find a bug in Unrar, but if you find it, you can burn it in Zimbra, and it just works. And this sanitize and modify pattern, I don't know what it's called for real, but it's just everywhere. Like in that case, if you look at the big picture, you can simply apply it and say, okay, it's validated, but know what? Is there some transformation happening somewhere later? I also think, and it's a simple take for me because I'm not writing mail processing chains, but I think we need better software in that case. Like Amavis should have been like evilly sandboxed from the start. There would be like your disparation, as this extractor should run as nobody in a shoot. So that kind of things could have been prevented like really easily. And when I say it's probably gonna lead to more bugs in the future, when I wrote this slide, I was kind of like, yeah, I think it makes sense. And then a few days afterwards, somebody said on the Zimbra forum, okay, somebody just uploaded JSP file in my public directory, just like we did with foo.gsp. And in that case, somebody exploited the same Amavis kind of bug for targeted attack, and they knew how to use Zimbra and stuff, so it looks like they know the targets. And they use the CPIO archive format, which supports symlinks and an absolute path to extract files to arbitrary destinations. And it's also crazy that like somebody's reporting it on a public forum and not to Zimbra. But in that case, this one has been fixed, but not fixed by removing CPIO, but fixed by telling users to install something else, which is before CPIO in the Amavis configuration. And same with LPs. I was just scrolling Twitter yesterday, and some guy said, yeah, okay, I just found another way to use another of the pseudo rules to execute code. So there is a link below. So, I mean, LP on Zimbra, like from Zimbra to root, is going to be a mess to patch, and it's going to happen a lot. So if somebody's running code at Zimbra, it's already over. They are already root. So if you have any question, I think we have time for 1 or 2.